Hello and welcome to Science Visualized. Today we're looking at a topic that's covered in both general and organic chemistry, that's structure and bonding. To start with, we'll describe what a wave equation is. A wave equation is an equation that describes all the behavior of an electron in an atom. So if you can have an equation that will fully describe all the characteristics and the behavior of that electron, that will be the wave equation. The solution to the wave equation is called a wave function. And the square of the wave function is called an orbital, which basically means an area in space which has about more than 90% probability of finding an electron. There are various types of atomic orbitals. We start with s orbital, then p, d, f, and g. The s orbital has only one type, and each orbital can be occupied by a maximum of 2 electrons, so that means s can have a maximum of 2 electrons. The p orbital has 3 types, px, py, pz. Each of those can be occupied by a maximum of 2 electrons. That gives you a total of 6 electrons. D orbitals has 5 d orbitals, and each of them can be occupied by a maximum of 2 electrons. So 2 times 5 gives you 10 electrons. The f orbital has 7 degenerate orbitals. Each of them can be occupied by a maximum of 2 electrons, and that gives you a total of 14 electrons. And we can continue, but we'll stop there for now. The shape of the s orbital is spherical. It's like a ball. It's a sphere. P orbital, the shape is dumbbell shaped, so like a number 8. And depending on where the p is oriented, so if you have x, y, and z axis, and let's say this is x, that's y, and that's z, then the px will be on x axis, so that will be px. Py will be on y axis, and pz will be on z axis. Remember, there are 3 p orbitals. And then we have 5 d orbitals, and this just shows an example, dxy and dz squared. But there are others. There's dz squared, dxz, dyz, dxy, and dx squared minus y squared. Now, there are some rules that are involved when filling electrons into the orbitals. The first one is called Aufbau principle, and that says that the lowest energy fills first. So think of a house that has several floors. If you have water rising up, it will start by filling the first floor, and then next will be the second floor. So you start with the lowest energy, so the lowest level fills first. Next, Pauli principle. It says that electrons can only occupy the same orbital in opposite spins. So for example, if you have an s orbital here, then the only way you'll be able to have 2 electrons, remember a maximum of 2 electrons, will be if they have opposite spins. So one is facing up, the other one is facing down. Hund's rule says that the orbitals will fill in parallel spins first until half full. So for example, if you have 3 orbitals like py, px, and pz, then the way we will fill that, if you have 1 electron, then it will just occupy 1 of that. If you have 2 electrons, then it will occupy, because these are degenerate, meaning same energy. So if you have 2, it will fill, the first one will go to the first p orbital, so py in this case, and then the next one will go to the pz. If you have 3 electrons, then each of the p orbitals will have 1 electron. And this is called parallel spin because they are all facing up. Now, when you have 4 electrons, first of all, you fill them in parallel spin, and that takes 3. So we finish 3 and we're left with 1. Now you start pairing. And when you pair, it becomes opposite spin. So that's called pairing. Now, using this, we can generate a diagram that we use for writing electron configuration. We start with the 1s. Remember, 1s has a maximum of 2 electrons, And then after that, we go to the second energy level, 2s2 and 2p6. After that, we go to the third level, 3s2, 3p6, then 5d10, and then next will be 6s2. By the time we get here, we'll be done with most of the transition metals. Now, the order of filling, which is called electron configuration, is this way. So you start with 1s2, so here, 1s2, finish. Next, you go 2s2. Next, you go 2p6, 3s2, so 2p6 and then 3s2. Next, you go 3p6, 4s2, so 3p6, 4s2. You go to the next level, 3d10, 4p6, 5s2, and then you continue like that. So for example, if you had 5 electrons, how would you write the electron configuration? We just need to distribute a 5 using this formula here. So it will be 1s2, 2s2, that's a total of 4 electrons. We are left with 1, so the next one will be 2p6. So instead of 2p6, because we're only left with 1, it will be 2p1, and that will be the electron configuration for that. Something like sodium has 11 electrons. Then the electron configuration for sodium will be 1s2, 2s2, so 1s2, 2s2, next is 2p6. That makes 10 electrons. We're left with 1. The last one will be 3s1. Thank you very much. If you enjoyed this presentation, please subscribe.